Why does a model perform well on a training data but fails badly on new data? That is called as overfitting. When a model is well and good on the training data but it fails to perform on the testing data. And the powerful solution to this is the ridge regression. Problem with the linear regression was in normal linear regression the goal is to find the fit the best line to the data, but sometimes the model becomes too complex, slopes weights become very large, model starts fitting every single point. This leads to overfitting, as I have shown you. So that is a problem with the normal linear regression, right? So what do we do is we do regularization. What is regularization? Don't let the model become too complex, controlling the weights. Ridge regression adds a penalty to the loss function. This is the loss function, okay? It adds the penalty to it. And normal linear regression is just finding the error of it. That's it. But here it will also add additionally the penalty for it, the weights loss for it. It is having the loss function, okay? And the extra form, that is lambda into summation of w square, is penalize large weights, forces weights to stay small. It will not allow it to increase its weight. Here the lambda is 0, then it is a normal linear regression, and the lambda is small, then it is slightly controlled, and a medium, then balanced model, large, then it is again becoming underfitting. Got it? So if weights become larger, w square will shrink the weights, that means loss increases. Okay, so w square becomes more large. W is only just small thing, but w square becomes more large, so loss increases. So model tries to reduce the weight, keep the model simple. So effect on slope, what happens is in linear regression slope is like m, so m can become large. Okay, m can become large, but in regression denominator decreases due to lambda, right? So slopes will get stringed. Important point is ridge regression reduces the coefficient values but does not make them to 0. It just reduces the coefficients, but it won't let it to completely fall down till 0. That is what the regression does. So normal linear regression gives the best fit line, and ridge regression gives you the best fit line, but keep it simple. Okay, as you can see the cost function for the normal is this, but here it is doing the square of the slope and also having the lambda. It reduces, like if m increases, m square more, it will be more increased. So what happens is loss will be increased. So our goal is to decrease the slope, right? To not just overfit the model. That is what it does. Normal slope is like this. As you know, we have seen in the linear regression, normal slope is this. But here in the ridge regression, normal slope will be like this. It will be having a lambda in denominator, right? In denominator, as the denominator increases, slope will be stringed, slope will be decreased. Due to lambda, the denominator will be increased and the slope will be decreased. So slope will be stringed. At the end, overfitting does not happen. So here again the intercept b is equals to y bar minus m x bar. This is the normal one we'll be doing. So m changes, then b automatically changes, right? It is a coefficient of this particular thing, right? So as m changes, the intercept also changes. In linear regression we have as I said, you will be finding the best fit line, but in ridge regression we'll be finding best fit line but in a simple. Okay, we won't make it when the model becomes complex also, it will make it to minimize, it will make try to reduce it. Coming to the matrix equation, this is for the normal linear regression. This is a matrix equation of it and matrix formula. And this is the Ridge regression matrix formula. Okay, so why Ridge is better? This makes the model more stable, reduces the overfitting, easier matrix inversion. And here everywhere we will be using lambda. That lambda will be having impact on all of the things. It will be trying to minimize the slope and works well when the features are highly correlated. So in real life data is noisy, perfect fit is not required, so Ridge helps to generalize better on unseen data. So in simple terms, Ridge regression controls more model complexity by shrinking the weights and reducing overfitting.